Hello, CP Algebra 1B, and welcome to 12.6, adding and subtracting radical expressions. We did multiplying, we did dividing, we now are moving into adding and subtracting, which you might think would be easier, but it's a little bit more challenging, okay? So just bundle up and we will, of course, tackle these together, and you'll be pros by the end of our unit, okay? First off, easy peasy, and that is if you already have common denominators, okay? When you add fractions, it's important to know that you have to have the same denominator. So here we have 8x, we have 8x there as well. We can add them right away, same denominator. This is just going to be, well, 3 plus 4 all over 8x, and hey, that simplifies to 7 over 8x. That is your answer, okay? Nothing fancy happens with the 7/8. If it was something like 16 over 8, you would simplify, but you can only add right away because, again, the denominators are exactly the same, okay? Denominators are the same, they're buddies, so they can add together, alrighty? Just like over here, only now we have the quantity, of x plus 1, okay? These are how we are going to start seeing our denominators, okay? It's gonna have to be this whole entire chunk. Well, again, the whole chunk is the same, okay? So maybe if we look at this as red and red, it's all the same. And up here, if you want to think, so we have minus, I'm going to think of it as a -7 and plus, okay? You can do that there. And really, you're just adding right across the top, so 2x plus 9 minus 7, all over the same old denominator. And that's going to simplify to 2x plus 2 all over x plus 1, okay? That is what it would simplify to. Maybe if anyone sees kind of what we did last chapter, so this is okay. If anybody notices, okay, what does 2x plus 2 have in common? Okay, you could really make that 2 quantity x plus 1 over x plus 1, and hey, that's pretty cool because now those are going to cancel out, and really, lo and behold, we're left with just a 2, okay? For right now, I just want you guys getting used to adding along the bottom, but if you notice something like that happening, that's awesome. So really it simplifies down to 2. Now, easy peasy, because we already had the same like denominator, but what we might have to do is find the LCM in order to add. So here, these are different, okay? 3x to the third, we have a 3. Here we have a 4, we have an x to the third, and here we have x to the fourth. Okay, we have lots of different things going on here. So I'm going to show this in one way here, okay? We have to find the least common multiple, or the LCD, least common denominator. Okay, first off, let's deal with these x's. So if we were to rewrite this denominator, it's like saying I have 3x times x times x. Here I have 4x times x times x times x. Okay? We need these in some way, shape, or form to be the same. So what I like to play is it's kind of like a puzzle. We need to fill in the missing pieces. Okay? So this fraction on the left, we'll call this left fraction. We'll call this right fraction. I know, creative. What would you say the left fraction is missing that the right fraction has? Well, the right fraction has a 4, and if you notice, it has an extra x. Okay, so we are going to multiply the left fraction by what it's missing. We said it's missing a 4, and it's missing an extra x. Now, when we do that, we also multiply the numerator. So you multiply by what it's missing. Now, what is the right fraction missing that the left fraction has? And the left fraction has a 3. This one is missing a 3, so I'm going to multiply it by 3 and 3. So you have to multiply by the missing parts. These are what is missing parts. Okay, so left is missing that, right is missing the 3. Now, it'll become easier as you go along, but let's just kind of see what this whole thing becomes. So the left fraction is 4x times 1, or just 4x. The denominator, you can just think of it as, what's 4 times 3? Okay, that is really 12. And x times x times x times x, x to the 4th. Oops. Oops. Now the right fraction is really 3 times the 5, which is 15, all over, well, 3 times the 4 is 12, and x to the 4th. Now that the denominators are exactly the same, it's like you're playing video games, and now you both have Xbox, x to the 4th box, okay? Now we can add them, we can play together, and we just have 4x plus 15 all over 12x to the 4th. Okay, that is essentially the name of the game. You want to get the same common denominator. Okay, so down here, if we look at number 2, okay, now we're getting a little more involved. But again, let's look at this as left fraction and right fraction. Left. But again, let's think of this as left fraction and right fraction. Okay? Again, if we also think of this as plus negative, that will just help us out in the near future. Okay, so change positives to plus negatives, or negatives to plus minus. Anyway, right fraction has this as the denominator, 3x plus 1. Left fraction has x minus 1 as the denominator. Okay, looking at these entire chunks, I would say the left fraction is missing the 3x plus 1. So this needs to be over there in order for them to play together. Okay, it needs a 3x plus 1, and you have to also distribute to 3x plus 1 up top. So this gets the entire purple piece. Now, what the other fraction needs on the right is an x minus 1. So we multiply the whole thing by x minus 1. I'll erase that just to show. Okay. So now that they each have both of the same denominators, just kind of showing you what happens. So 9's going to distribute to the 3x and the 1. That means I have 27x plus 9. Negative 15 is going to go to negative, or to the x and negative 1, meaning I have minus 15x plus 15. And the cool thing about the denominators is you can just rewrite them as these big nasty chunks. It's x minus 1. And notice again, these are the same. So now we can just add right across the top. 27x minus 15x is going to be 12x. 9 and 15 is going to be 26. All over 3x plus 1. Quantity x minus 1. Okay? Again, for right now, I want you to be multiplying by the LCM. Okay? This is the last one for the notes for right now. We will get into factoring in a little bit. But I again want you to find the LCM. So here's the right fraction. Once again, here's the right fraction. Here's the left fraction. Left fraction is missing something. The right fraction is missing something. Okay, it looks like we're missing an x minus 4 and an x minus 4. Here we're missing a 5x and a 5x. Okay, again, I would encourage you to use some colors if you need. And don't forget to now distribute. So 12 is going to the x and the minus 4. Down below, we just have x minus 4 times 5x. Plus 5x is going to the 3. So 15x squared. X times x is x squared. All over x minus 4, quantity 5x. Same denominators, so now these are happy because they can play together, and that just means we have 15x squared plus 12x minus 48. I'll let you leave it like that there, and again we have x minus 4 and 5x. Again, for today, I just want you focusing on what is the LCM and how do you multiply it. So don't go ahead and factor just yet. We'll be doing that in the future. Oh, it looks scary, but we'll be okay. What I would like you to do is, hopefully you have some room over to the side here, is problem 4. And here's what I'd like you to try and also submit on your essential question. So 1 minute here as everything organizes out. Here is 4. And if I give you the fraction 3 over x plus 1 plus 2 over x minus 3, alrighty, I would like you to tell me what the LCM is. So here are your posts. 1, tell me the LCM, so it should be in the form parenthesis, 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 parenthesis. 2, you don't need to post, but I want you to finish the problem and show me. And then something silly for number 3, I want you to post this, so stars are what you actually put on Google Classrooms. And star, I would like you to, if you noticed, I have some movie music playing in the background playing, so tell me your favorite movie. Yes, has nothing to do with this, but that's what I'd like you to share. So Google Classrooms, try the second problem, show me when you're done, and that's all I got for you today. Thanks for hanging on out, Algebra 1s.